In this video, we're going to talk about classifying polygons and different types of polygons based on their sides. So first off, in geometry, a figure that lies in a plane is called a plane figure. A polygon is a closed figure with the following properties. It is formed by 3 or more line segments called sides. And then these next two are a little bit different based on the book, but this is the easier way of thinking of it. It needs to be a closed figure, so there can't be any open pieces. Think of it needs to be filled in altogether, so completely covered around each other. So like over here, it's completely closed. There are no curved edges, is the biggest one to look for. So each endpoint of a side is called a vertex of a polygon. The plural of vertex is called vertices. Vertices. A polygon can be named by listing the vertices in consecutive order. For example, in this figure on the side, we could start with A, so we would do A, B, C, D, E, or if we start somewhere else, if we start with the letter D, we could go D, E, A, B, C, are 2 correct names. So if you notice, I went in clockwise direction. There are 2 types of polygons, and that's a convex polygon and concave polygon. And if you notice, I underlined the word cave over here because a concave polygon basically just means it's not convex, but the easiest way to notice a concave is it caves in on one side. So if you notice over here, that this part over here, it kind of caves in. So that's concave versus convex, just connects all the way around the outside. So classifying polygons is named by the number of sides. And the names for a 3-sided figure for a polygon is a triangle. That one you definitely should already know. You probably know the next one. So 4 is a quadrilateral. Next would be 5 sides, and that is a pentagon. So think of the Pentagon building. Has 5 sides and is shaped in a pentagon. 6 is a hexagon. 7 is a heptagon, so almost like hexagon, so heptagon. 8, you should know that one, that's your octagon. 9 is a non-agon, so non-agon. 10 and 12 are very similar. If you notice, 11 skipped over for a reason. There's no specific name for an 11-sided figure, but a 10-sided figure is a decagon, and a 12 is a dodecagon. So there's lots of other figures, but there's no specific names for them, so we just call it an n-gon. Is what that's going to look like. So going off that last part on the chart, the term n-gon is where n is the number of sides, so it can also be used to label a polygon. And for example, a polygon with, let's say, like 15 sides would be a 15-gon, and that's literally how you would write it on your paper and you classify it. So in an equilateral polygon, all sides are going to be congruent, just like an equilateral triangle. In an equiangular polygon, all the angles that are inside your polygon are going to be congruent. So notice not the exterior, it is the interior angles. And we'll talk about exterior angles later. So a regular polygon, this is definitely a new word in this one right here. So a regular polygon is, it has to be convex. So remember that for later. So if you have a concave figure, you can't have a regular polygon. And it needs to be both equilateral and equiangular. So you can see in this figure on the right that all of our angles are all exactly the same. And we have all sides in that figure are also congruent to each other. So in these two problems, or these four questions right here, I'm gonna do the first two with you, and then these are going to be on your own. So in these first two, we need to first say yes or no, is it a polygon? And then next we need to see if it's concave or convex. So in this first one, this would not be a polygon because of that little piece right there, because that makes it almost two separate figures instead of only one. This next one would be yes, it is a polygon. We're looking for any curved places and nothing connecting inside. And then next I need to see if it's concave or convex, and this would be convex polygon. So go ahead, push pause. I want you to work out the next two, and then push play when you're ready to check your answer. All right, so this first one, you should not be a polygon because of that curved edge right there. This next one, you should have said yes, and it would be concave because of these little pieces right here where it caves in, and we only need one of those for it to be concave. In this next example, so example 2 right down here, so we need to classify it by the number of sides, the polygons, so we're saying that all three are polygons, and you need to classify it by the number of sides, then tell me if it's concave or convex, and then write if it's equilateral, equiangular, regular, or it could also be neither or any of those. So with this first one, this has 1, 2, 3, 4, 5, and 6 sides. So this is a hexagon. Next, we have to tell if it's concave or convex, and this would be convex because there's no pieces that cave in. And for equilateral, equiangular, or regular, we see that all angles are congruent, and we see that all sides are congruent. So this would be a regular polygon. Okay, so the next one, we can see that there's 4 sides. This would be a quadrilateral. Then we can see that it's also convex. And for these sides, we can see that there's different sets that are congruent, and same thing with the angles, but not all of them are the same. So this would be neither. So it's not equilateral, it is not equiangular, and so it cannot be regular since it's not either of those. So I'd like you to try this one on your own for letter C. All right, this one has 12 sides. This is a dodecagon. You can see that it caves in on the sides. This would be concave. And then, because it is concave, if you remember from before, it cannot be regular. So even though all of the sides are congruent, that part works, but the angles are not all exactly the same because technically we have this angle on the inside part that is not the same from this 90 degrees. So this would just be equilateral, and that's it. This question we're going to do together, and then the next example you will do on your own that is similar to it. So this says that a table is shaped like a regular hexagon. So remember, hexagon is 6 sides. Regular means that you've got sides and angles that are congruent to each other. And you can see that the expressions right here are the side lengths of the hexagonal table. We need to find the side length of the table. So first we need to find the x. So because that we have a regular figure, we know that these two pieces, all of the sides really, will be congruent to each other. So we can write 3x plus 6 is equal to 4x minus 2. So we can solve for x. So I can subtract my 3x over. So I get a 6 equals x minus 2. Then I can add my 2 to the other side. So I get 8 equals x. But that's not what the side length is. So next I need to find the side length. So I need to take this and I need to put it into the x portion of that. So we'd have 4 times 8 minus 2. So this will give me a 32 minus 2, which would be 30. And this is in, let's see, inches for each of the sides. So my side length of each of my sides of the table are 30 inches. On this question, I want you to work it out yourself. So I know there's no picture of it, but it does tell you what shape it is. It's an equilateral triangle, and that's all that you really need to know to set the equation up to solve for x. So go ahead, push pause. When you're ready to check your answer, you can push play. You can see in my picture that I drew an equilateral triangle, so all three sides are congruent. It just tells us that two of the side lengths, so two sides, are the 6x minus 10 and 3x plus 14. So it doesn't matter which ones, because really they're going to be equal to each other. So you should have set up 6x minus your 10 equals your 3x plus 14. If you subtracted your 3x on both sides, you would have had a 3x. Oops, my x looks a little sloppy there. Minus my 10 equals my 14. If I add my 10 over, then I get a 3x is equal to 24. So my x again is 8 when I divide by 3. But again, you want to find the lengths of the sides. So if you took that, you should have taken that number and then plugged it in for one of the sides. So 3 times 8 plus the 14. So 3 times 8 is your 24. And then plus the 14. Combine those together and you end up with a 38. And this is, let's see, feet for the side of our equilateral triangle.